Okay, so here's the problem that I was saying that is, I think, number 29 in your book. So first it says the marketing manager at Levi Strauss, whatever, wishes to find a function that relates the demand D for men's jeans and P, the price of the jeans. The following data were obtained based on a price history of the jeans. First of all, does the relation defined by the set of ordered pairs represent a function? All right, so the very first thing you have to do is what we were talking about earlier on in the week. Decide if this is a function or not, just based upon the ordered pairs. So with this, what you're going to find is that whenever, goodness. There we go. Whenever you look at these are your x values, right? And here's your y. And if you have more than one x going to two different y's, then it's not a function. So right off the bat, we see these 23s here going to two different y's. So we can say no, this is not a function. All right, so that's as easy as it is for the first one. Now the second one, all right, the second one, whenever we're doing this, we have to first input the data, just like we were doing today in class. Input the data like we were doing in class. So I went to stat, edit, and I went to L1 and I put in 20, 22, 23, 23, all that. And then L2 I put in 60, 57, all of those. So if you need to, pause right here and input that so you can follow along with me. Alright, so now that you've got those in, second quit. Now go to stat, go over to calculate, scroll down to len reg, press enter. And for those of you who have the other viewing, it'll say X, L1, X list, L1, Y list, Y1, or L2, and then the frequency, always leave that blank, and then when it says store reg EQ, that's where you're putting in the Y vars, or the Y1. So you need to go to vars, Y vars, enter, enter. So your first line should look like this. You should have len reg, Y1. Press enter. So now, before we do anything, we know the equation of this line. Alright, so before we even go to graph, we can write down the equation of this line. We know that's going to be y equals negative 1.3355p plus 86.1974. And this isn't y, this is d. That's the variable they gave us. Alright, so our slope, our y-intercept, because it has our a, we know our a is our slope, our b is our y-intercept. Alright, so we've got the line already, we already know the line, so we can go to y equals, and here it shows us what our line looks like, and we can go to zoom 9, and now we have our data plotted and our line drawn. So we can see about what that looks like. So we've got A, B, and C. Now we need to interpret the slope. Alright, so interpreting the slope, first of all, we need to know what the slope is. We know that the slope is negative 1.34 about. That equals m. And so what that means is we have to go down 1.34 and then we go over 1. Well, we have to think, what are we talking about when we go down? Remember, we're always talking about y when we go up or down, and we're always talking about x when we go left or right. So in this case, we have to think, okay, well, what's our y value? We have that over here. It's the demand, the pair of jeans sold per day. So we know that the demand is here, and we know that x is the price. So when we are talking about the context, we can say if the price went up by 1, then the quality sold per day decreased by about 1.34 pairs of jeans. So basically, they're saying if we're looking at rise over run, if we're looking at the y first, we say if demand for jeans went down 1.34 pairs per day, then the price would decrease by $1, or would it be increased by $1? And when we think about the slope, that makes sense because we're saying if the price goes up, then the demand goes down. All right, that's what that's saying. When we go forward by $1, we're saying we're increasing $1. It's going forward by $1. Then the demand goes down. So for every 1.34 pants that are sold less per day, that's saying that the price is going up by $1. You can also say it the other way. For every time the price goes up by $1, the demand goes down by 1.34 pants per day. All right? Now, what's the domain of this function? We have to think about what our x and what our y represents. All right? So, oh wait, first, I'm sorry, I skipped ahead. We need to do E. E asks us express the relationship using function notation. All right? That is something as simple as saying, normally we would say f of x equals negative 1.34 x plus 86.2. Right? That's our normal function notation that we're used to. But it's just asking us to explain, express it using the notation that they gave us. So now instead of f of x, we're just saying d of p. So it's no longer a function, it's saying the demand of p equals negative 1.34 p plus 86.2. Alright, that's just a different notation. That's not a big deal. Now the domain is like this the last problem that we were doing in class. We were saying what's the highest grade you could get? Well, you couldn't get over 100, so that restricts the domain. Well, the same thing is true here. What's the domain of the function? Remember, that's the x values, that's p. So we're saying do we have any restrictions on our pairs or on our price of pants? Well, the restriction, hopefully you can see, is that the price of the pants can never be negative. You are never charged a negative value, so we have to say that the domain has to be greater than 0. Our p value, our x value, has to be greater than 0. Alright, then finally, how many pairs of jeans will be demanded if the price is $28? That's as simple as plugging in 28 for p and seeing what the domain would be. And if you plug that in, you would get about 49 pairs of pants. Alright, so hopefully that helped. If you need more explanation, just shoot me an email, tweet at me, and I could possibly make another video. Alright, good luck on the homework.